I think we're finally ready to train our own Yolo v5 network in Colab. So if you haven't watched, there are two previous videos to this that you should probably watch before doing this video that are, let's see, one is using label image to label images and create your bounding boxes. And the second is uploading that dataset to Roboflow in order to create a dataset you can then use in Colab. So watch those two before you jump here. One note I want to make is in the Roboflow version, or the Roboflow video, I mentioned that you didn't have to separate out test, train, and validate folders, and the Roboflow folks reached out to me and said, hey, you should definitely at least create a validation set because the model does use validation to tweak performance a little bit. So mistake on my part. I'll mention here in the video as we walk through this where the validation set works. But I definitely recommend making a data set that has a training data set and a validation data set. You can probably do 80-20. You might not need a test set. Like what we're going to do in this video is actually upload our own test set once we've trained our network. But just be aware of that and make sure you do that before following this tutorial. So this is a tutorial written in a Colab notebook. It's actually written from the Roboflow folks, so really appreciate them putting this whole thing together. It's a really great resource and makes the whole process pretty clean and easy. So we'll go ahead and get started here. So we're going to reconnect to our Colab notebook. And then you can go ahead and I think this tutorial is actually pretty straightforward. If you read all the text here, it's pretty great. There is also a corresponding blog post that you can follow along with if you want to. These two work in tandem, but I find the Colab notebook is enough as is. So first thing we're going to do is we're going to install our dependencies. And as always, shout out to Colab Pro. Highly recommend if you can, if you're in the US, using Colab Pro because as you'll see here, we are using a Tesla V100. So this is going to be nice and fast for us. V100s are essentially like the most recent version of a GPU server that you can get. I guess the A100 is the brand new one, but I don't even know who's using those or if those are even out yet. So this is a really nice fast machine and a highlight of Colab Pro. $10 a month and you can use this many times. So it's pretty great. Next thing we're going to do is we're going to pull in our data set. So this is using the Roboflow code. So in the other video, I think I showed you how to do this. Basically, you go into their system and you look for get link, and it provides you this link. It says you shouldn't share this because this key code is like unique to you. I'm going to delete this data set after this video is recorded, so you can try this and it won't work for you. But you should have your own special code. And Roboflow is free. It has like a free tier that's pretty cheap. Or I guess is free, and will work for something of this process. So we're going to go ahead and run this cell. This is going to download a training set and a validation set, and we'll look at where those get moved to. You'll see here I have a training set and a validation set, and I even have a test set. I guess I did like 80-20-0, or probably like 80-10-10 or 70-20-10, something like that, for the breakup. Okay, so next is we have there's a bunch of YAML files we need to edit in the Yolo v5 version. So we're gonna go ahead and take a look at those. The first one is data.yaml. So cat just sort of says read this file into the system. So see here we're gonna use the training and validation set. So that's gonna point at train and validate, and then how many of our how many categories are there here. So this is my 5 Instagram cats. So you'll see that there are 5 label categories here. So next cell we're going to do is we're actually just going to save this NC to a variable called num classes. And then what we're going to do is we're going to take a look at the various flavors of Yolo v5. So excuse me. So one thing to note is that there are a couple different versions of this. And if you look in models, you'll see there is Yolo v5L, v5m, v5s, v5x. So this tutorial, when you actually go through and look at the notebook for the first time, is going to work on 5s. 5s is the smallest. It should be the fastest, but it might be less accurate. So you sort of have to play off like, do I care about accuracy? Do I care about speed? What am I sort of looking for here? I'm going to work off the 5L. In just looking through the notes of various things, 5L and 5x are pretty close in terms of accuracy. 5x just takes a little bit longer to train, so I'm going to use the 5L. So this probably looks like 5s when you open it. So if you just edit this to be 5L, you'll read in all of the These are basically the attributes you're going to use for v5. So you'll see here right now it's defaulting to a number of classes of 80. So we're going to edit that and make it to be 5. So this line just basically allows Colab to be able to edit files. And then we're going to do a write template. So we're going to rewrite this file to include that number of classes variable here. And I should note again, make sure that this says 5L or 5S or whatever you're editing it to so that it edits the right thing. Cool, so this is now set up to be 5L, and we're pretty much ready to start training here. One thing I should mention before we start training is in this cell here where you were writing your template, if you're going to use 5L, make sure that everything below this line matches everything you've read into this line, right? So if you read in 5S and you basically, like, the way this is set up already is it'll load in all the 5S settings. So make sure this matches. Just be sure of that. One note that because I am sort of familiar with this, I might have jumped over that, but make sure that these files all match, except for this num class, right? Because you want to make sure that this is updated with however many classes are in your Roboflow files. Okay, so let's start training. So in the training line, there's a couple things you can edit here. The first is your input size. I'd probably leave this at 416. It's probably it's good. You don't want to make it any bigger or any smaller. Batch size, I'd probably start by leaving it at 16. You might be able to get a little bit larger out of this particular data set, or sorry, on this notebook, but maybe just leave it there just to make sure it trains first. Epochs is generally set to 100 maybe in this file. But there's a good note here that this is something you want to train for a while. So, if you're doing this by yourself, you might want to set it to 3,000. I'm going to set it to 1,000 for this, just so it trains a little bit quicker and I can come back and do the demo really quickly. We're making sure we load in that data.yaml file, which is this file. So make sure you have both a train file and a valid file, as well as your class names here. Make sure that this model is set to whatever setting you use. So if it was 5S, you leave it at 5S. If it's 5L, you leave it at 5L. And then I think everything else here is good to go. So we're going to start with 0 weights, and then we're going to create a Yolo 5. Let's switch to 5L results, and then we're going to cache everything. So this is good to go. So we can go ahead and run this cell. And you'll see all this as this runs, it loads in the network. And it's caching a bunch of images. And we're ready to start training. So you'll see here that it is running 1,000 epochs, so 0 to 99999. Definitely think we can upgrade our GPU size. It looks like we're only using maybe 2 gigabytes of memory, so we could probably bump that up a little bit, but maybe let's take a look as this trains further along to see how it goes. You'll also see that as it trains, it outputs a map score. I've talked previously about what a map score is in the runway demo of using Yolo v4. You want map as high as possible. Clearly, since we're starting with 0, very low, since this is the first couple iterations and epochs of training, it's going to start really low. My guess is that I'll get to about 85, maybe a little bit higher percentage. Ways to get higher scores are to feed it more data and just have a really good training set. But since we only have 475 or so training examples, my guess is this will get to around something over 80, but probably not much higher than that. So I'm going to stop this recording. When we're finished training, I'll come back and we'll take a look at how to use the rest of this. So I'll see you in a minute. Okay, so I'm going to cheat a little bit and pull up a file that I've already trained. So you'll see here in runs, you'll see Yolo, EXP, which is experiment 0, Yolo v5L results. And that's the file that we want to work with. Basically, this contains all of the training weights and a bunch of other things for us. I'm actually going to delete this EXP1. Not sure why that didn't work here. Oh, maybe it did. Yeah, it did. Okay, cool. So let's take a look at how we can sort of check how our training went. So we're going to use TensorBoard. TensorBoard will basically allow us to take a look at all of the training samples that we ran. Let's go ahead and run this cell. Sometimes this takes a minute. There we go. Cool. So you'll see here that this is our, these are just a bunch of metrics from our scores here. So you'll see that the training started very, very poorly, right? Because it started with nothing. So it starts pretty low. And as it gets higher and higher and higher, we get a better score. And then we also sort of see our score kind of flatlines here, right? So maybe the top of our score was 0.8591. So that's an 86% accuracy. Looks like it maybe got a little bit higher here. And then you'll see precision recall. We'll see our loss. So we'll see our loss kept going down. Now this is maybe indicative that so I trained this for 1,000 epochs. I could have maybe trained this for 3,000 and maybe gotten a little bit lower because it didn't really like bottom out. And I think there's probably just a chance here to maybe train this for a little bit longer. So if I were to do this for myself, I'd probably train it for a little bit longer, but this looks okay for the moment. So now let's go ahead and actually view what some of the results look like. So this is going to read in a file, and it's going to let us look at sort of what our scores look like. And I think this results.png is the wrong path. Let me just see here. Yeah, so I think I want this path, which is copy path. Let's actually run this and see what happens, but I think it's going to be wrong. Yeah, so I think I want this. And no module name utils. So let's load in. Interesting. What's going on here? Let me see if maybe I missed running a cell. Okay, well, maybe we can't look at those. I'll have to debug that in a minute. I feel like I've had this work before, though. So let's actually run this, which is, this is going to show us what our ground truth data looks like. So here we've got, I believe this is the right folder, test batch 0 ground truth. Yep. So this is a batch of images that we sent to the network. Obviously, this shouldn't look surprising to you because this is everything that we've already trained on. And then this cell is going to show us what the second training batch looked like. So basically, what it trained on. So you'll see here, like, this is part of how Yolo v5 works, in that it like sort of collages a bunch of things together. It does a lot of transforms and manipulations, and this is stuff that over time we've learned works better for object detection, right? It allows us to sort of manipulate images, and the machine learns better using a lot of these techniques. So now what we can go ahead and do is we can actually take a look at what our best and last results were. So one of the nice things about this particular network is that it will save out the best scored like weight file. It'll also save out the last. So in many cases, your last weight file is not going to be your best, and what you actually want to run off is the best one. So if you look inside of ls runs, and then you look inside of the weights, you'll see there's a best and a last, and we can look at that right here. So best and last. So what we're going to do is we're going to do an inference run on the best the best weights, because ideally that's probably like the best scored version of the model, and that will hopefully give us the best results as well. So I'm going to stop this video for 1 second, just upload my my data set of image files that I want to do inference on, and then we'll come back and take a look at how this works. Okay, so I've created a new folder here inside of Yolo v5 called 5cats test, if I can read correctly. So all I did is, because I had a huge file of images already set up, I just pulled them over from Google Drive using gdown, and then I unzipped the folder here, and you'll see this is probably some like 1,500 images in here, and there are just images of cats. So we're now set. Once you have a data set here, you can actually use, if you wanted to, you could use your test set of images that came from Roboflow. There's probably like 20 in here or something. So you could use that if you built a test set using the percentages instead of Roboflow. You could do that. I'm going to show you, like, this is what happens when you train on, like, or when you run inference. Gotta talk slower, Derek. When you run inference on your whole rest of your data set. So if you remember way back at the beginning of me starting this lecture, I broke out like 500 examples to create a training set, but then I had 1,500 other examples that are going to be now tested on. Okay, so anyway, what we're going to do now here is we're going to run the detect.py script. Our weights are inside of our runs folder, so make sure that whatever you pass in here exists. So if we go to, let's see, not Yolo v5, we go to runs. experiment 0, Yolo v5, L results and weights and best. So this is the file that we're pointing to. You could run last, but that might be not your best example. So you want to make sure you run on best, the best weights. Image 416, this is fine. Again, I don't really care what size I'm running this at because I just want to get the inference labels out and then run that separately to actually do the cropping. Confidence score. So this is sort of up to you. If you set a really high confidence score, you'll get less examples of things that worked. If you set it lower, you'll get more examples of places where the confidence of the model was a little bit lower. Up to you. So we're going to go ahead and copy this path. And we're going to paste this in. So our source is where all of our test images are. So we're going to go ahead and now run the cell. And this should run pretty fast. Inference is like a pretty quick process. You'll see it's already churning through, and there's actually, wow, okay, there's 4,700 examples in here. But you'll see it is running through, and it is already finding every image. What I love is it found one instance of Venus, which is now Venusis. But you can see as this runs. This could, I believe, almost run real time. If you want to do real time, I might recommend using Yolo v5, the small example. That one will probably work best for something like real time. But this is already processing through. And if I go and look in this folder now, it's going to take forever to open because now there's like double the amount of files in here. There'll be like 9,000 files in this folder. But if you open this, and if I find a good example here, or one that works. Oh, you know what I did wrong here? I know exactly what I did wrong here. I'm going to stop this. So in order to get out text files, you actually need to pass in a different command. So to do that, you actually have to run, I believe it's --save _txt. Let me actually double check this real quick, because I think that's the right thing that I want to pass in. Inside of Yolo v5 and inside of detect. Save, so it's a dash. So it's --save -text. So we're going to pass that in, and that will save out text files for us. And those text files are what we're going to use in yet another video to actually do our cropping. So run this again. Now it's running, and if I hit refresh here once it's open, and let's see if there's a text file in here that we can run off of. This might be really hard to do. I might actually want to run this on the test set generated from Roboflow, because this is going to be really hard to do. Okay, let's try that. It's just going to take me forever to find. It's like finding a needle in the haystack. So let's actually do this. So let's copy this path. And let's pass this in. I'll do this for myself later, but this is way too hard to actually show as a demo. So let's paste this in, and let's run this. There's only 20 examples in here, so it'll run very, very quickly. And we should be able to find a... No images are found in content.test. Oh, you know why? I have to pass it the images file. So let's go test/images and run it again. Cool, so there are 35 images in there. And if I go here, you should now see, let's refresh this folder. Results saved to inference.output. Okay, so that's the other issue, is that this saves out to a different place. Let's go to Yolo v5. Let's go to refresh. We'll go to inference, output, and here is the JPEG. And here's the TXT file. So what does this TXT file mean? So funny thing, Yolo v5 has slightly different coordinate systems than the Yolo v4 model you might run in Runway. So this means, so the first one is 1. That's the corresponding label that exists with. So I guess if I just look at this, it's apparently Hamilton. I'll have to do a lookup to actually see like how these all match up, but I'm sure it's working right, so because that is Hamilton. And then these first two coordinates are the XY of the center point. So it is the XY of, let me do this. It is the XY of the center point of the box, and then the outside, I believe, is the bottom left corner. So basically it sort of just like does a box from there. So it like doubles whatever it is and like puts it up here as well. So it's a little tricky to like sort of keep that in your mind, but that's basically what we're doing here. So what I would do with this now that I'm finished is I would probably just zip up this output and export it or like download it or maybe move it to Google Drive. And when it's done, then what I'm going to want to do is I'm going to want to bring it into my dataset tools library and actually do some of the cropping. That is a work in progress, and I will show a video on that pretty soon. But just pretty cool. You've got everything you want here, right? So you've got your images. Interesting, that's not right. You've got your output. So you've got outputs with images and TXTs. So what we're going to do is we're basically going to throw away these JPEGs. They're helpful to just sort of see and like have them as an example, but we're probably not going to use them very much going forward because it just sort of tells us like, yeah, this thing's working right. But we will use the .txt files to do better croppings and generate a data set from that. So that pretty much covers everything in this video. I know this is a long one, but thank you for being with me, and I hope you figured out how to use Yolo v5. If you have any questions, please drop me a note either on Slack or on YouTube, and I'm happy to help where I can. And I'll see you next time. Thanks.